Hey guys, so we're going to look at bone growth, and I'm re-recording these videos, so it's my second time around, and sometimes when that happens, I go faster or I do less. I tell fewer stories because I'm just trying to cover the content. So enjoy what you get for this round of video. Here we go. Okay, so with bone development, we have two types, intramembranous ossification, which we'll talk about now, and endochondral ossification, which we'll talk about next. So let's start with the overview. So all of these ossification happenings start to happen about 7 or 8 weeks prenatally. So when the embryo or the baby is in the womb. There's fibrous connective tissue involved, hyaline cartilage tissue. So these bases are what form the loose structure on the cellular level of where the bone is going to model or grow. This is going to occur until age 25, so it's an ongoing life process, and bones in general are always continuing to be built and broken down, right, remodeled. So they're quite alive and changing. So let's look at the ossification centers of this image, right? So here there was a fibrous connective tissue, and that's where the osteocytes went and developed bone. And as you can see here, this is at 9 weeks. We get a little bit of bone development, and then further on down, 12 weeks is more bone development. And you can see the facial bones as well growing around in this area. Okay, the first phase of this is happening rapidly between weeks 8 and 15. The fontanelles are where there's still some of that intramembranous bone or connective tissue left over. So when the cranium is coming together, like all those parts of the bone are coming together, there's a space of soft connective tissue in between, and that's known as the soft spot or a fontanelle. What does this allow? Like, why doesn't the cranium completely develop? Well, in general, babies are born prematurely. Like, if you think about the horses when they're born, how they can walk very shortly after birth. They're a very mature creature when they come out. However, humans are very immature, and the reason that is that they are having such big heads that if they were to fully develop, they wouldn't be able to enter the world through the narrow pelvis or the birth canal. So anyway, so that's why we're a little bit different, and when we're born, we're not quite ready to walk the planet. So the fontanelles, the soft connective tissue between the bone, allows for shaping to happen, and what that means is that the cranium inside the womb is like kind of shaped like this, and then as it passes through the birth canal, it starts to get cone-shaped, the cone-shaped baby head. So that is temporary, and it will go back to normal, although it can be shocking for new parents. One other thing is, again, just that while the baby in the infant stage is growing, it'll also allow for expansion of the brain. So room for the brain to grow, the head keeps growing and allowing for that space. These are the ones that specifically experience the intramembranous ossification, all listed here. Here's the fontanelle that we talked about. This is the last space that will close. Here in the anterior portion, there's a bit of a posterior one as well, as far as spaces go, where those three bones, the parietal and the occipital bone, meet. Yeah, so there's that fibrous connective tissue that we were talking about. Okay, phase 2. What happens in phase 2 is that everything is going to ossify, and that's the phase that's happening until adolescence. So if you think about the facial bones of a child versus an adult, right? That changing in the facial structure happens during the second phase, and it is completed at the end of the adolescent growth period. So at that point, it's basically a stable facial feature, uh, facial recognition, facial features that that person owns at that point and will look like that for the lifespan. So this is how it happens on a microscopic level. Okay, so basically, um, the what we see in the slide are mesenchymal cells, right? That's like your building block that's um, going to change into, has the potential to be any cell in the body, a mesenchymal cell, but the DNA is what determines what cell it becomes. So here a mesenchymal cell is going to become an osteoblast, right? And the osteoblast is going to secrete the osteoid, and the osteoid is what is going to build that bone around the blood vessels, and we'll see that here. So this is, it's official, this is the ossification center. So what we see here are the osteoblasts secreting the osteoid. The osteoid signals the attraction of the mineral deposit, which builds that bone. So we have that here. Inside, we have a trapped osteoblast, which then becomes an osteocyte. Okay, because it's living within the bone cell now, it's mature, and it is within that lacuna. Okay, so that ossification center is happening in a space where there's also blood vessels. So the ossification continues, and it continues to build around the blood vessels. So it doesn't squeeze them or cut them off, but it forms, it only builds the bone up around them. So that's how we get that trabeculi pattern, and also allows for the bone itself to be penetrated with nutrition. So that's how it's built up. The mesenchymal cells that are here in this area will condense and form the periosteum around that bone tissue. So here we can see the osteoblast continuing to work and deposit the osteoid, which brings in the inorganic matter as well to build the bone. And in this area, this is called the bone collar, because it's forming a compact bone around that area. The trabeculi can turn into compact bone, leaving the space, or in certain places it remains with that spaciousness, and that is the spongy bone area where bone marrow will develop. Here you can see how the mesenchyme cells lined up and the fibrous tissues all lined up to form that periosteum. So this is just a quick slide for sutures, and this is a mature adult cranium, okay, and you can see the sutures here, and just what's being illustrated is some irregular sutures, right, that we don't always see in normal growth and development. The reason I'm putting this is for our med notes, right? So in our med notes, what happens at birth is that they're going to assess if the fontanelle is opened or closed, and normally the fontanelle will be closed, not open. Having any opening where we're not expecting it can be cause for pause, for intervention, because we want things contained inside structures that need to protect them. Sutures are, so the other assessment, which is why I showed the suture slide, is just the sutures. They need to see if they're overriding or approximated. So they do assess that immediately at birth. What's not assessed, okay, is the length of the fontanelle, the frontal bone, to determine brain development or early diagnosis of congenital diseases. So this is a hyperlink here. It's an article on research to try to help decide if we can actually do early diagnosis of these things based on the measurements at birth. And And what they found in the study is just that there's a lot of statistical significance in relation to the size versus um, the labor, the mother, the male or female. So there's a lot of different variables that are going to impact the measurement here. And then therefore, there's more variables to account for in order to be able to determine an early diagnosis. So a lot of more research will have to happen before this can become something that's standardized. In delivering a baby, this you can also use the fontanelles to determine head position. Sunny side up is when the baby comes facing upward. Sunny side down is when the baby comes up facing downward. And this is the most prevalent one that happens, and it's the safest for everybody, and it's the easiest transition. So the baby's head comes out. Here she's facing down, and then turn its head. So the baby has to do the work, tuck the chin, and then turn the head when coming out.